again, we have functions. This is telling me my possible inputs or my domain or real numbers. This is telling me my possible outputs or my codomain or real numbers. And this is telling me my function. So y is equal to e to the x plus 2. They want me to determine the value of c, where if we look at this, and it does tell me, it says this is where it cuts the y-axis. What do we know about something that cuts the y-axis? We know that the point is 0 something, so the x is 0. So anywhere I have an x, I'll replace it with a 0. And I should be able to find out where it cuts the y-axis. So that is, anything to the power 0 is 1, plus 2 is 3. So the output is 3, so c is 3. So we have 0, 3 there. And the next thing is determine the range. Okay, so the range is your actual outputs that are, you know, used. And we can see here, it doesn't, none of these outputs down here seem to be used. It looks like the graph is kind of going to level off there. Maybe, I don't know, that's 3, that's 0. So it looks like it's not gonna go much below there, you know. You might want to actually graph this, or even just see what it looks like back here. It's worth doing that. Or throw it into GeoGebra just now so you can see, not in an exam, but just now so you can see it if you want to see that it's never actually going to go below. It looks kind of like that line there. So if we're looking for how low this will go here, we're looking where the x values are minus numbers. And we're looking maybe off back here at minus 100 or minus 1,000. So let's just see what happens if we threw in, if x was maybe just like minus 10 and plus 2. So there's my function where the input is minus 10 and that would be 2. So the output would be 2. Okay. What if the input was minus 100? So minus 10, 2. And it's not 2, it's almost 2 though. What if my input was minus 100? Okay, so it seems to be limiting at 2. Maybe I jumped a bit there, so if you want to, you can go back and try minus 20. Okay, that's very close to 2. Minus 21. It doesn't seem as though it's going to go back before it's going to get any lower than number 2. I'm not even sure it's going to touch 2. It might just get very, very, very close to it. So minus 21, yeah, getting closer. And then that's why when I pressed minus 100, like it's going to go from 2 all the way up. And I don't think it'll ever really touch the number 2. It'll get very close to it, insignificantly small details. So that's why the calculator is rounding it off at 2 all the way up to infinity. So I found the value of c, and I also, for the second part, I found the range. The range is your actual outputs. Okay, state whether or not f is bijective. So first thing I might be writing is bijective means injective and surjective. To see if it's injective and surjective. Injective is a one-to-one mapping. Or you could also say, check and see if it passes the horizontal line test. Yes, it does. So one-to-one mapping, yes, injective. That's yes for that one. And is it surjective? Does the codomain, is it the exact same list as your range? No, it's not. Okay, that's all real numbers is my codomain. That's the actual range. We've left out loads of y values. So no, it's not a surjective. So not surjective. Range is not the same as the codomain. And to me, that's enough. I mean, if you want to explain further, this is your range. Well, I don't feel the need to. And this is your codomain. They're not the same list of numbers. So 2, 3, 4, 5, 6, or 2.1, 2.2, all the way up. Okay, find the coordinates of the point where the tangent of the curve crosses the x-axis. Okay, so find the coordinates of the point where the tangent, so I'm just going to write this in because the tangent is just a line. I know this from junior cert. The tangent to the curve at that point there, where it cuts the x-axis. So I think I need to get the equation of this line. I have a point in it, 0, 3. Now, do I have the slope? So my ways of finding slope are to either go to my log tables and see if I can find anything in the coordinate geometry section, or possibly try and use differentiation. Okay, because if I have the formula for the function, then differentiating it means I have the formula for the slope of the function. So I think I'm going to go with that. If I want to differentiate e to the x plus 2, and then that's just actually e to the x. So that's the formula for the slope of the curve. And we want to know what the slope is when the x coordinate is 0. So the slope when the x coordinate is 0 is 1. So the slope is 1. So there's my point, x1, y1, and there's my slope. So y minus y1 is equal to m bracket x minus x1. Y minus 3 is equal to 1x. That's the equation of the line. How do you find out where a line cuts the x-axis? You let the y value be 0. So x is minus 3. And if I look back here, even from my sketch, that kind of looks right. About minus 3.